All right, let's go ahead and get started. Hi, everybody. How is this beautiful spring day going for you? Great until right now, I'm sure. All right, so a couple announcements. I'm not going to have office hours on Thursday again. I have this physical therapy, and I got to get my knee fixed, and the only time they could do it was during office hours. So instead, I will have office hours today, as usual, from 1:30 to 3, but I will also have them tomorrow from 2:30 to 4. Okay? So tomorrow instead of Thursday, if you were planning on coming to talk to me. Anybody planning on coming to talk to me? Okay. All right. I was thinking of like other models of education where maybe you can get the class for free, but you have to pay to come to my office hours. What do you think? Or to take the test or something like that? No? You're fair. All right, so last time we were talking about classes. What is a class? You answered that last time. Somebody else who's not looking at their notes already. Yes? It's a blueprint that contains what? Public. It's a blueprint that contains public and private things, which are... Yes, they work to create... What is in the public and private section of a class? Yeah? Yep, methods, which are functions, and data, okay, inside there. So a class is a collection of data and functions on that data. Methods are what we call those functions. And the overall point of this is it's a blueprint. When we call one of these classes, we say make a point class, make a person class, it creates an object that has data and methods that can work on that data. An object is what? Yes? An instantiation, a thing instantiated from a class, so it's actually built from that blueprint. You've moved over one seat, it's very confusing for me. Okay. And then what is a method? I just said it 3 times, yeah, Abby? Yep, a function that's part of a class. We've talked about a bunch of different types of methods. One of the ones we talked about is a destructor. What is a destructor? You're making eye contact. You screwed up. Yeah, when does it get called? Before the end of the program, the Nope. The method, a destructor is a method that gets called automatically as soon as that object goes out of scope. Remember we talked about scope. Sometimes variables are good, sometimes they're not. When an object goes out of scope, when it goes away, the destructor is called. Okay. All right, we have getter methods. What do these do? Ah, you screwed up. A getter is also known as an observer, and what does it do? All right, it's a method that gets data out of an object, also known as an observer. It lets you observe the state of data inside. Okay, I'm going to ask another question, so now it's time to avert your eyes. Yes? No, not at all. I mean, you can also, the getter method gets data from inside there. So right now we've seen private and public. There's also something called protected, which we're not going to worry about for this class. You can have a getter method that gets any of those. So if you had, say, a public data member, which isn't always very common, you could have a method that gets that. No, not necessarily. However, you could have that getter method do other things like format it or cast it to a different type, things like that. Does that make sense? So you could still have a method even though it just depends on your algorithm, right? The answer, of course, for this question is when you ask me, can you? The answer is almost always yes. It's just when do you want to? So you can't do that. All right, so if we have getter methods, we have setter method. What's the setter method? Yes? Yep, it's something that lets you change in the object. It lets you alter the data in there. What is one of the things that we can use our setter method to do that's useful? Yeah, error checks, right? We're putting data into an object. We can use this method to actually do some verification that the data going in is what we expect. And these are also known as accessors. All right, so last time we were going through an example of this, talking about the point class. And the point class It's the simplest class we can possibly imagine that puts two ints together inside an object, and it represents a point on the Cartesian plane. So what I would like to do is I would like to go back and look at this point class again. And I just want to step through it one more time to make sure everybody kind of understands the flow of control. So this is the point class we did last class. And you can see, we'll just step through the description really again. Class point means we're bundling a bunch of stuff together. What is point with the open close parentheses? A constructor. And point int, what is that? It is also a constructor. It's an overloaded constructor. It's overloaded because we have multiple methods that are doing the same thing. The first one just creates a default point. The second one allows you to give it a particular value. Okay. All right, we have an observer method, which in this case is just draw, or observer in this case just prints things out. It doesn't really turn anything. We have a couple of setters that allow us to set the data, and we have a destructor that gets called automatically when the object goes out of scope. Again, this destructor isn't really important. It will be important in objects later. Right? So I just want you to know that it's there and it does things. And then, of course, we have the private data portion, x and y. So here are all the methods that we do. One of the things we do in our constructors is we print out when the constructor is called so we can see what's going on. And we print out when the destructor is called. This is atypical. You do not have to, when you write your own classes, print out every time something is called. I'm just doing this because one of the confusing things about classes, the thing that makes them hardest to understand, is the flow of control, right? When we started at the beginning of the semester, where do you start? You start in int main and just go line by line. If there's an if statement, you go one way. If there's not, you go the other, and everything's nice, straight, right? Don't you remember those good old days, back when it was easy? Back when things were simple. Okay, then we got to functions, and functions work differently. You start going along at main. When you see a function, you have to jump over to the other part of code and start going through there, and that function might call other functions, which calls other functions, and it gets more complex. Classes are somewhat confusing because now the flow of control is not always totally explicit, right? It's not always, you started in main, but then point appears, and you have to know that the flow of control suddenly jumps over to the constructor. And then when point goes out of scope, you have to know that it automatically calls the destructor. Okay? Does this make sense? So I want to step through this so that we have in our minds how this flow of control works. Yes? Sure. Like say you have a for loop for int x equals 0, x to 3. That variable x only exists inside that loop. In our program that we're going to look at right here, right, pretty simple, point 1 and point 2, it goes out of scope as soon as you reach the end of the method, right? This has block scope only inside those curly braces. Just happens that this block is the main function. Sir? It is not like closing a file that you open. Closing, you actually have to close. Variables go out of scope automatically. Like they just go in. Yes, the point of making, one of the things you can, yes, the point of making a destructor is when things go out of scope, it allows you to clean up anything you've done in that object. In fact, if you have an object that opens a file, one of the things the destructor can do is close that file to make sure it gets closed. So, yes? Yep. So we haven't yet seen why we need a destructor. And we could spend a lot of time talking about it, but the fact is I'm just going to keep lying to you and telling you that it's necessary without telling you why. And then, like in a week or two, we will actually get to why you need it. Does that make sense? So I try to organize everything in the class so that I don't have to like forewarn you about things, because then everybody's like, why do you do that? I'm like, I'll tell you next week. But nobody's happy knowing next week. Everybody wants to know now. No, for the code due in Project 4, I don't know that you needed a destructor. No, no. I didn't even put it in my code. So, because if you don't need to do anything, the compiler will create one for you that does nothing. So, all right. So we're looking at this code int main. Where do we start? If we want to figure out what this program does. Int main. Where do we always start every single time? Where do we start? One more time. Who is your best friend in this language? Int main. Every single time. If you don't know where to start, just look for int main. You think I'm joking. I read code professionally, and the first thing I do when I go in there is I find int main. They will give me code that's like tens of thousands of lines, hundreds of thousands of lines, huge pieces. You know the first thing I look for? Int main. Seriously. I feel like I've failed as a teacher that you all don't appreciate int main. Int main is fantastic, okay? All right, so we start in int main. We go down. The first thing we reach is 0.1. What is this doing? Makes a point. What if this said int? What if we said int x? What would you say this did? Let's add int x. What does int x do? It declares a variable named x. What does 0.1 do? Declares a variable named. And what type is int? What type is x? And what type is 1? A point. It's exactly the same. But a point is a class, and in order to see what the class does, we have to look at the blueprint. Where do we find the blueprint for the point class? Up above. Okay, so we see that something's being created, 0.1, and we go, aha, point must be a class. We have to figure out where it's created. Let's go take a look at the point. So I'm going to split the screen in two, horizontal. How's that? Is that better, or do you like it stacked? Is that better? Okay, so let's go take a look and see what point does, all right? So we see, aha, 0.1, and here is a constructor, point, that takes no arguments. Does this 0.1 have any arguments? It does not. Therefore, we must be looking for this constructor. And look, we found it right here. Point, we know arguments, it belongs to the point class. We set x equal to 0, y equal to 0, and we print something out. Once again, why are we printing things out? Just so you can see what's going on. It is atypical, okay? Atypical to print things out. We're only doing it for demonstration purposes. So we can see this creates a point. We can see this point has two private parts, x and y, and they're both set to 0. Once this constructor is finished, where does the flow of control go back to? Right? Because flow of control is what step we're looking at. We started in at main, we found 0.1, we realized there must be a constructor, so the flow of control jumped right over here. We do all these lines of code, and then when we're done, where do we go back to? Yep, the end of this line, we're done. Now, 0.2, what are we doing here? Yes? Okay, we're declaring a variable named 2 that has a what type? Remember int x? This is exactly like int x. We're just declaring something. It's just that because we have created the blueprint for what we're declaring, we have to go look and see what that does. Okay? So even though it says point and that seems confusing, it is exactly like everything else we're doing when we say point x, string, name, whatever. It's a declaration, variable declaration. It's just that for classes, you have to jump and look at the constructor. So we say 0.2, 5, comma 5. This looks different than the last constructor we saw, didn't it? Why? What's different about it? It's got some 5s in there, right? The last one didn't have any 5s. So we go look at our class definition and we say, aha, here is something that matches. There's a constructor called point. It takes 2 int. Is 5 and 5 2 ints? Yes, it does. So now we know what to look for. And we head on down here and we go, aha, here it is. Belongs to the point class. Its name is point. It takes a new x and a new y. X equals new x, y equals new y. Print something out. Is it typical to print things out? No, it's not. Okay. So once we do all this, where does the flow of control go? Right back here. After we execute that, the constructor happens automatically. We go right back there. Now we come down here and we say 1.setX. What is going on with this? Who'd like to tell me what's going on here? I've got a crunch bar in it for you. Yes, sir. Okay, so what we're doing is we're calling a method on variable 1, which is a point, all right? We set it up here. Do you remember what was inside this? What was inside 1? 0, 0. So we look at this and we go, aha, now we're operating on 1. It's part of the point class and we're calling setX. Let's go take a look at the thing. Oh, look, here's something called setX. So we know that's part of the point class. We know that's a method that can be called. It's being called on object 1, the one named 1, O-N-E, right? As compared to the other object, which is called 2. So we have two distinct ones. So let's go look and see what set x does. So we scroll around here, we go, aha, here's set x. X is equal to the new x. So we call set x with 7. What happens inside point 1? Right, remember before we had x and y, which were the private data members were 0 and 0. Now we call set x with 7, and so what's going to be inside this point now? 7 and 0, okay? Everybody good with that? And so when the flow of control is done, after this method is done, where do we go back to? Go right back to the end of this line, we go on to the next. 1.setY7. Anybody have a feeling how this is going to work out? The whole thing is it's going to be 7, 7, but how do we get there? We see there's a set y. We go look in the class definition, and we say, aha, there's something called set y. It takes an int. That's 7. Now let's go down and see what set y does. Oh, look, there it is right there. Y is equal to new y. So again, we're dealing with the one object, which we knew inside had a 7 and 0. But now we're changing the y to 7. So when we're done, object 1 now has 7 and 7 inside of it. Go down to 1.draw. What does 1.draw do? Yeah. The answer is it's output. We know that because remember last time. But if you don't know because you're seeing something like this on exam for the first time in your life, where do you look? You look at the class definition and you say, aha, is there something called draw? There is. Okay? We can go look at it. Let me ask you a question. Why do you think each time I'm going up and looking at the class definition instead of just looking through all the methods that we know are there? Yes, sir. Yes, because a couple of things. We want to make sure that it's public, not private, and we want to make sure that there isn't different versions. Okay? We haven't quite seen this yet, but just like you can overload constructors and have different parameters, you can overload other methods too. So you want to make sure that when you're looking at the right thing. Okay? So I'm just jumping up here to look at it to make sure it matches what I'm looking at, even though it's pretty obvious it does, and then we look for it. And when we go down to draw, here's what we see. It says it outputs drawing point at x comma y. So what is this going to output? 7 comma 7. Okay. All right. We're done with this line. We return 0, reach the bottom curly bracket, and the program ends, and we're all done, right? What do you mean no? We have to call the destructor. Okay? So what will happen is the destructor will get called in what order? Essentially reverse order. Not that the order is important, but what will happen is first the destructor will be called on 2, then the destructor will be called on 1. So let's look at how the destructor works. We go, we see if there's a destructor. There is. There's only one. We won't talk about overloading destructors because that gets wacky, okay? If it's even possible. And all this does is tell you which one it's printing out. So it says destroying point at x comma y, and the first one's going to be 2, which is 5 going to 5. And the second one's going to be 1. It says 7 comma 7, and then the program's done. Okay? Everybody understand how this flow of control works? Because when I give you on an exam a new class you've never seen before, you're going to have to be able to do this. Okay. Yeah? Sure. Which side do you want this one? Nope. It does it automatically. Just like when something is created, the constructor gets called. As soon as that object goes away because it's out of scope, or it reaches the end of the program, because when the end of the program happens, everything goes out of scope, then the destructor is automatically called. Okay. Yeah? It would actually destroy 2 first. If we run this program, it destroys them in the opposite order they were created. Now, on the exam, I'm not going to take points off if you do it in the wrong order because I don't care that much. I just need you to know that the destructor gets called. Okay. The order in which things get destroyed is not as important as the fact that they do get destroyed. All right, who's with me? Who's against me? Let's stand up for 1 minute in place because I just talked for 20 minutes straight. All right. Welcome back from your break. How are you feeling? Does it help? No? We'll never take a break again? All right. Points are awesome. Right now, all we can do is set them, print them, and destroy them. Is there anything else we might like to do with points ever? Like what? Okay, so everybody wants to go ahead and make the points make a line, and I promise you we will get there. It's just going to be a little more complex. Let's do some simpler stuff first. And I'll tell you why it's going to be more complex. Because if we have 2 points and we make a line, then we're probably going to have a line class. And the line class is going to have 2 points inside of it and have its own set of methods for manipulating the line. And I don't want to go on to the second class yet until we work out some of the stuff about the first class. Okay. Sir, what would you like to do? All right, so we have a request to add points, and I think I mentioned that at the beginning of last class. So let's talk about adding a point. So we have a particular point, and what we're going to do is we're going to add another point to it. Does that sound right? So if we have point 1, we want to be able to add point 2. What does it mean to add 2 Cartesian points together? Math major. Sorry, you don't have to be on the spot if you don't want to. Yeah, to sum the x coordinates and sum the y coordinates, right? So all we want to do when we add 2 points is to add their coordinates together. All right? Sorry, I like picking on math majors. Anybody else a math major who wants to be picked on too? So you're a math major too? Okay. I'll split the load between you then. So. All right, so we're going to add points together, and all this really means is we're going to add x's to x's and y's to y's. Okay? And the way we actually want to be able to do this is we've created this method. I've said it's void add point. What does this mean? What does this method return? It doesn't return anything. What's its name? Add, which implies what is it going to be doing? Adding. And what does it take as an argument? It takes a point, right? Just like we've been using ints and things before, once we create these classes, we can use them for parameters, we can use them for return types, whatever we like, okay? So here's how this is going to work. We've created add point, and what we want to do down here is we want to say something 1.add 2. So we're adding point 2 to point 1. Now let me ask you the question. When you see something like this, 1.add 2, does this match any of the prototypes that we've created? Yep, it matches the one we just created. We're calling a method add. It has a point as an argument, and there it is. Questions so far? So this add is going to be a little bit different than another add we've seen before, because this add, when we're done, it's going to end up with point y's value. I'm sorry, we're going to end up with point 2's value added to the value inside point 1. Okay? So this method says take the values in point 2 and add them to whatever's in 1, and when we're done, 1 is going to contain the results. All right? Good? Thumbs up? All right, so let's go ahead and write this. How do we write a method? What does this look like? Here's our prototype over here. So what do I type over here? Void, the return type. Point, : y. Because that's how we know which class that method belongs to. The way we differentiate functions from methods is that a function has a return type, a name, and some parameters, whereas a method has a return type, the name of the class it belongs to with a couple of colons, and then the name of the method and its parameters. So we're calling this add, and what does it take as an argument? Another point. And what do you want to call this? Anybody have a name they like for their parameter? Just add new point. We had new x, new y, so let's make that new point. Okay. I'm going to make the font slightly smaller so it fits more neatly on the column. Can you all see that? Yes? Oh, we'll get there. We will. Yes, right now he's saying we're adding the contents of one point to another point internally. This isn't how we normally think of adding, right? We normally think of like A equals B plus C. This is like A plus B gets stored in A. It's a little bit weird, right? But we will get to the point where we're doing, we'll do that next after this. So here we are. We are inside this class. When we call this, let's look at what's going to happen. We're going to call one.add. One.add is going to say, okay, I'm working in class 1, or an object named 1. So anything I have in there, x and y, is going to refer to the x and y I've been working with, which at this point is 7, 7. Right? And we're adding something from this new point. Now what's happening is just like before, 2 is getting copied into this parameter when it gets called. So now, how do we add the x value from that other point into our current point? So we have this outside point, which is going to be a new point, and we have our current x value. How do we add those things together? All right, this is where it gets a little weird and confusing, right? The thing to remember is that when we call this on one.add, we are working inside a particular point object named 1. Everybody got that? Just like when we did one.setX, one.setY, one.draw, we're all working in point 1. Now we're doing add. So anything this add refers to is going to be referring to things inside add. So if we say x equals something, which x are we referring to? The one that's inside the point named 1, and we know that value is 7 because we just went through that. Okay, so we're going to set it equal to x itself plus something. What is it we're trying to add to that? Pardon? The x value of the point named 2. Well, point named 2 got passed in as a parameter. It got stuck over here in new point. How do we get that x value out of there? Yes? Use the getter. And how do we do that? That's it. The same thing happens for y. The y value, caps lock. The y value is equal to the current y value plus the incoming new point dot get y. Yes? Yep. Okay, so the question was before when we had like mood in a person that was a public data member and you could just alter it at your whim. We generally don't, in general, we don't use public data members. Okay, most of the time we don't. I gave that as an example because it does get used sometime, but not as frequently as private data members. Had x and y been public instead of private, we could just do newPoint.x or newPoint.y, but x and y are private in this, so we have to use the essentially, oh man, I screwed up, didn't I? Because we don't have a getX or getY for this. Okay, how about we just write one really fast to make all this work, because we should have done that before and I forgot. Ready? Oops. So the add function is in the point class, but it can only access the private data member of the current object, not of any object. Does that make sense? Okay, sorry. So I screwed up. I need to add int point : get x, which is pretty easy. No, that was a cut and paste error. I'll fix it in a sec. Sorry. So I did a bad job of making sure I had all of the observers. It's funny because sometimes when I'm writing these things up here, I look and like when there's a lot of confusion on your faces, I'm like, I clearly missed something. Let me look at my code and see what it was. If only the computer were able to do that for me, like if I had a picture of a face on my screen. All right. Yes, sir. Yeah. Sorry, I cut and pasted stuff, and I wrote the actual methods correctly. All right. Sorry about that. Okay, so all my careful construction went to waste because I forgot to talk about, even though we had setter functions, we did not have getter functions for x and y. So I added those, but they're pretty straightforward. They just return the value directly. Okay. Everybody with me now? How many people did I lose by making a mistake? All right, nobody's willing to admit to it, so I'll pretend that everybody knows what's going on. All right, so let's step through this flow of control again. All right, everybody happy with this add now? What we're saying is that the x of the current method, the current object that we're operating on, gets added to itself plus the x that we are getting out of this other point that's passed in. All right? Yes, we could have done plus equals there. I just figured this notation is a little cleaner. So, yeah. Exactly. This is why it gets confusing. And so let's actually step through and look at this, okay? Everybody with me? So we've written this stuff. Actually, let me just make sure it compiles. Okay, good. Okay, so the question is, how does it actually get this? So let's just step through this again. We'll go quickly. We're going to start from int main, okay? And we'll step through everything again just to make it a point. So we started int main. We go to point 1. What happens when we get here? The constructor gets called. I'm not going to go into the constructor. Remember that. We get to point 2, and what is the value assigned to the x and y private data members in point 1 by the default constructor? 0, 0. Okay. So now we call point 2 with the other constructor, and we create a point. And what are its x and y values? 5 and 5. Right? So we have 2 points. And actually, I'll draw some stuff on the board, though this won't show up on the video. All right. So here are 2 objects, and you can literally just draw a little box for these. And there's stuff inside the box there. All right. Does that help conceptually to see what's going on? Great. Now we call one.setX. Which one of these objects out of 1 or 2 is being modified by this setX call? How do you know that? Because it's 1 dot. So we know that we're calling a method on the object named 1, right? And what are we setting the x value to? 7. So what gets changed inside this box? That 0 next to x gets changed to 7. Everybody with me on that? Make sense? Okay. Now we go down and we call the setY method. Which object between 1 and 2 is getting called to set y? How do you know? Because it says 1 dot. So we know we're operating on 1. And then what are we changing inside here? Y. Change that to 7. And we're good, right? Our next line we call 1.draw. And which object between 1 and 2 are we calling draw on? Is it, I'll give you 50-50 chance, 1 or 2? Which one? How do you know? Because it says 1 dot, right? So we call draw, and what does draw do? Just outputs what's in there, and what does it output? 7, 7. Everybody with me so far? Okay. Now we're calling one.add to. This looks wacky, doesn't it? Which box, 1 or 2, is add being called on? How do you know? Because it's just like everything else, right? One dot something means we're operating on this box that has 1 in it. Now, the thing about it is that this is getting a parameter, and the parameter is 2. Which box is 2? The other one, labeled 2. So we're calling add on the box that says 1, but the parameter is this other thing 2. Right? So really it looks like this. It's like 1 dot add 2. And this thing is being passed as the parameter. Okay? With me so far? Now, let's jump into this code and we say, okay, let's look at the add method. And the add method's right here. And we say, look, it matches, it's taking a point. And now we have some code. We have to say the x inside 1 is equal to x plus something. Plus what? X plus, it's right up here at the top of the board, right? X plus what? Getting the value of whatever was passed in as a parameter. So we look at it and we say x equals 7 plus new point, which is going to be the name of this copy, right? Is this passed by value or passed by reference? Is there an ampersand? There are reference parameters in methods, by the way. We haven't gotten to that yet. But. Okay. So we say 2. So 2, we have to call get x right here on this thing 2. What is x inside here? 5. So this becomes 7 plus 5, which is 12. So what is x inside object 1 now? Changes it to 12. We go on to the next line and we say y equals new point dot get y. Okay, which y are we talking about? 1. And why? How do we know it's 1s? Because we're doing 1 dot. And then we say new point, and which is the y in the new point? The 1 and 2. How do we know it's the 1 and 2? Because that was the parameter that was passed in right there. So we say 2 is new point get y. We look in y. In here we say, okay, get y is 5. So this whole thing is 5. 7 plus 5 is 12. So this gets changed to 12 as well. So that's what our program does. Now let's just prove that this actually works by doing 1 dot draw, and we can see if it actually compiled and runs and does everything that I claimed that it did. All right, clear. Wait. All right, so here's what we see. We see the constructor creating the thing at 0, 0, which is what we expect from this line right there, right? We see the constructor, hang on, I'm going to move this up to the top of the screen. We see the constructor creating a new point at 5, 5, which is what we expect right here. We don't do any output for set x or set y, so there's no output. But then we call 1.draw, and we see drawing point at, bad grab, drawing point at 7, 7, okay? All right, now we see this destroying point at 5, 5. Where the hell did that come from? Something went out of scope. What went out of scope? Okay, this is where it gets baffling. What ended up happening is we passed this parameter 2 in, and it got put in this point right there, which is the parameter. Does that make sense? It gets copied over. The values get copied over. So inside these curly brackets, and only there, does this new point exist. Okay, it doesn't call the constructor because it's copied. It's not creating a new one. It's copied the old one. And I probably should have taken the destructor out because it's just confusing. But what we're seeing is once this method is called, this new point parameter goes out of scope. When it goes out of scope, the destructor gets called. That's a little bit wacky. Well, the first time it's destroying this copy right here. The first time it's destroying the copy that was made in the parameter. Yeah. Because this parameter only lives inside these curly brackets. And so when you call .add, it creates this new copy. It does stuff with it, and then once this function, this method is complete and it goes back, the stuff that was created for that method goes away. And when it goes away, it automatically calls the destructor. No, the destructor is always going to get called. Always. Anytime one of these objects goes out of scope, the destructor gets called. The way I should have stopped this was by taking the print out of the destructor, because it's a little bit confusing to understand, and that's not what I'm trying to show you right now. Yeah. It didn't destroy 2, it destroyed new point. Okay? Yep. Uh-huh. Yep. What would happen is when you called that add function, it would create a new copy of the add function. It would create a new point, use it, and then when it was done with it, throw it away. Does that make sense? Yes? New point were a reference parameter with like an ampersand and destroy new point, or would destroy both? So the question was, if it were a reference parameter, and the answer was, is that it wouldn't actually call the destructor because of the magic that reference parameters do. Because the thing that it was referencing wasn't destroyed yet. Okay? Other questions? This was kind of a sidetrack because I forgot that I had the printout in the destructor. Yes?
Okay, so I guess like when you do one.add
Mm-hmm. Yep.
that's when it goes out of scope, but then it goes through the whole new like add function or method.
So
Destroys it not just like when it uses the main.
yeah, it's destroying. What's ended up happening is when we call one.add, it creates a copy of this method. Okay? And what it does is it copies this value 2. Stop it. It copies this value 2 into new point. And so new point gets created, but because it's a copy, we don't see the constructor. And then it uses new point for these 2 lines, and once it's done with this, and it's done and it returns, new point goes away. When new point goes away, it calls the destructor. Yes, when it's copying 2 into new point exists only inside this scope right there. Only exists inside that method. Remember when we talked about scope, we talked about parameters having parameter scope? It's an example of that. Okay. How's everyone doing? Sorry about the derail there. I wasn't meaning to talk about the destroying point, but there it is. And then finally we see drawing point at 1212, which is actually what we wanted, right? Because we added 1 to 2, and then we drew it, and we saw that, and we were very happy. Yes, who was happy? And then we see that the original point, this is point named 2 gets destroyed. This one was point named new point. And then we see the point 1 getting destroyed with its values of 12. Okay. Everybody good? All right. So the first thing I'm going to do is I'm going to go through and I'm going to take out all these printouts and these stupid constructors and destructors because we don't really care about those right now. I should have done that before. Okay, now I'll be happier. So it's not usual to print those things out. And let's just compile it, and we'll just see what this does without all the constructors and destructors. 7, 7, 12, 12. All right, who's happy now? Questions? But you can see what's happening here is when we do one.add, it is referring to, it's calling add on the object name 1, and it's passing as the parameter object name 2, and then we have to get x and y out separately for those things. Does that make sense? Yes? Okay. Yep. Yep. We wrote the constructor to do it 0. Right there. That code. So we actually built the constructor. If we didn't explicitly put that constructor in there, the compiler would put one in for us that did nothing, which meant that x and y would be initialized to whatever random variable was there. Okay, makes sense. All right. Who thinks this stuff is a little bit weird compared to what we've been seeing before? It is. It's a change of thinking. So. Who wants to be condemned to add things like that for the rest of their lives by doing .add? If you're smart, you'll raise your hand. Who wants to see how to do it the hard way, the way that we're used to with plus signs and stuff like that? All right. Let's take a 1-minute break in place. Absolutely, yeah. If you create your own class, you can use it for anything. You can use it anywhere you used in or float. You can use it as a parameter or return type or whatever you need. That's exactly what we're going to do next, is overload our add operator so that it returns a new point. Yep. Okay, so let's get started again. So we decided that adding things this way sucks, right? 1.add sucks. How would you have to do like x.add y forever instead of x plus y or something? That sucks, doesn't it? So here's what we're going to do. We're going to write a new method for adding, and instead of working on a particular thing, what it's going to do is make a new point object. So here's our prototype of it. Point add point. And then this says, instead of doing nothing and returning nothing, return a new point that is the addition of these 2 points. Nope, we don't need 2 parameters yet. We absolutely can. This is what's called overloading, okay? Just like we overloaded the constructor, we're now overloading the method called add. Overloading means to have a method or function with the same name, but that has a different return type or different parameters. Ooh, wait a minute, you're right. I don't think we can overload this because we don't have different parameters. Let's just see what the compiler says. It's going to say, you're right. Okay, so we're going to get rid of this one, okay? So we didn't like our old add because it didn't work well, so we're going to replace it. Thank you for pointing that out, okay? We're going to replace it. And what we're going to replace it with is an add that instead of putting things internally, creates a new point that has the sum of the things in the other points. Okay, everybody with me on that? Sir? Nope. We do not. You think you might need to pass in 2 points, but we don't, because we're going to do something crazy like this. Okay, yes. Yes. We'll get there today or next class. I'm trying to build up to that because I don't want to just jump into it because it's more complex. I want to make sure you understand this isn't baby steps anymore. This is like toddler steps. And I don't want you to fall down and smash your face on the coffee table because it's glass. It would hurt. Okay. All right. So here's what we're going to do. Now, instead of just saying, 1 is going to do what's in there, we're going to actually create, hang on a sec. I'm going to, what I should have done is I should have saved a different version of this before. Okay. stuff back. Okay, so now we have this other version of point. What we're going to do is instead of our adding affecting one point, it's going to return a new point. And the new point is going to be the sum of the two. And it's going to look pretty similar, okay? It's going to look pretty similar. All that's really changed about adding is not the way we're doing adding, but where the results end up going. Does that make sense? So the adding itself is going to be exactly the same. It's just that instead of putting the results back into one of the objects that we were adding on, the one that it was called with, we're going to stick it in a brand new object. And that new object will have the results in it. Who's with me? Does that make sense? Okay. So here's how we do this. We actually have to create a method that matches this. So here's our prototype in the class definition. Here's where we're calling it. What does the method actually look like? Anybody want to help me out? Point. Yep. Point. Boy, that word point shows up a lot in there, doesn't it? All right. So what does this mean? We're returning a point in a method from the point class called add that takes a point as a parameter, and we're just calling it new point as a parameter. Okay? This is pretty similar to before. Now, I can either do this the compact way, or I can do it the way that makes sense. Which would you prefer? How many of you say compact? How many of you say the way that makes sense? Yeah, I figured. Okay. All right, so what we're going to do, we're going to have an X for output, and we're going to have a Y for output. How do we figure, and this out X and out Y are going to be the X and Y values of the new point that we are passing back. Okay? How do we compute this X, this out X? Yep. So what this says is we're going to have a new X value. It's equal to X. Which X does this refer to? The private data member in 1, because this is, we called it from 1, whoops, down here. Hang on a sec. Right, we called it from 1. And this new point dot get X refers to which X? The one that was passed in a parameter, which we can see over here is actually 2. How do we do, who wants to help me with the out Y? Yes? Yep. So now we've computed our X and Y. We have to pass back a point. We are returning a point. How do we return a point that has the X and Y value that we've created? Yes? Exactly. We're returning a point that takes as parameters out X and out Y. So this is saying make a new point. It goes to the constructor and it says, oh, it uses the constructor that has out X and out Y, and it returns that point that we have created. And where does that go to? It ends up down here in 3 because of the equal sign. So now if we do 3.draw, please work. And if we run it, oops, wrong program, same output. Okay. Huh. Somehow we drew 0.1 twice. Oh, 1, 2. Okay. All right. Everybody see what we did there? Yes? Everybody see where this addition is coming from? When we say .add means we are operating inside one of the objects and we have direct access to its private data member. The other object that's passed in as a parameter, we have to use getX and getY because it's private and you can't just reach into private parts. Okay? I didn't mean to make that joke. I really didn't. I just found myself in a conversational corner. All right. So, how many of y'all like this way better than the way we added before? How many of y'all think this way still sucks? What do you want to do? Okay. So it would be nice for other people who wanted to use our point class if they didn't have to use our stupid .add method, right? Because when you think of numbers, you don't think of like 6.add4 to make 10, do you? Do you? Yeah, the math majors in particular are shaking their heads, so I trust their opinion. What we really want to do is something... oh no. Sorry about that. I made a mistake. Oh, come on. Okay, what we really want to do, let's put that back into threes. All right, what we really want to do is we really want to be able to use the plus sign. So instead of saying 1.add2, wouldn't it be better if we just said 1 plus 2? How many of you like that better? All right, how many are willing to suffer through a little bit of code craziness to get there? More people like it than are willing to look at it. Okay, what we're going to do, so far what I've showed you is I've showed you like a couple of different ways to do add that work as methods. What I'm going to show you now is called operator overloading. Operator overloading. Have we heard the term overloading anywhere before? What do we hear that in reference to? The constructors. The idea of a constructor overloading means you can have different methods that are constructors that even though they have the same name, they do things a little bit differently. The idea behind operator overloading is that we as people and as programmers and as math doing people have this expectation that there are certain operators we can use, like plus, minus, times, divided by, equals, stuff like that, right? And we want to be able to use those operators even on the classes that we have to build ourselves. So when we build a class, when we create one, if we want to be able to use these operators, we have to tell the computer how they work, okay? We have to tell the computer how they work. Now it turns out that it's not that different from what we've been doing. To do operator overloading instead of method or function overloading isn't that different. There's just a particular way of writing the operator so that the computer knows we're trying to define an operator. So let's go ahead and do that. And what I'm going to do, actually, I'm going to keep, would you rather have main on the left or right? I'll give you your choice. On the left, and then we'll write our function over here on the right. Okay, so what it looks like is this. Well, it's going to be kind of the same here for the most part. What it looks like is this. First, we have to go up, and in our class definition, tell what we're trying to do. And it looks like this. We're trying to create a new point, right? That's going to be the sum of two other points. And what we say is that it is operator, and then the operator we want to define, which is plus. Okay? So what this says is that you're going to have a point, we're going to return a point as a part of an operation that uses the plus sign, point, like that. Everybody with me so far? Yes? Can we put anything in place of that, like plus sign? Yes. You could put absolutely any symbol in place of plus sign. You can write whatever operator you want for your thing. In fact, if you were an evil person, if you were a horrible, despicable, suck person, you could write a class that when you use plus actually erase the hard drive or potentially set the computer on fire if you could figure out how to do that from software. Okay? The idea behind this is that you can write the operator that does whatever you want. It's just that you have to pick things well so as not to screw over other people who are using your code. Yes? This is not a void function, no, because we are actually making a new point that is going to be the sum of two other points. Okay? Just like we did before. When we did this add, we made a point that was like the sum of two other points. All right. So it's going to look really similar. Very, very similar to what we did before. I should just check my notes to make sure I don't totally screw it up. Okay, so then what we write over here is we've done, this is our prototype, and what you'll be telling the computer is that when you see something that's a point that also has on the left side of the plus, that's also a point on the right side of the plus, to go ahead and use this method. And the way we do it is we do the same thing, point, colon, colon, operator plus, that takes a point, and what do you want to call this? How about new point, because that's what we've been using, even though we're running out of space in the column there a little bit. There we go. What do you think, what code do you think has to go inside here? Pardon? It turns out that the code that goes inside here is identical to the code that goes inside our other method. Identical. We are writing something that works in exactly the same way. It's just that instead of writing it in a way that does .add, we are writing it in a way that does the plus sign. Yes, sir? Okay, now your question is, how the hell does this end up working, right? Because how does it know which point to work on, right? Is that where you're going with that? Let's look at that. So his question was, if you have a plus sign here, and you only have one new point in the parameter, how do you know which point object we're working on, right? Because when we did one.add, it was pretty clear that one.add meant, you know, you're calling it on the add method. But when we do something like this point, when we do something like this, it says, you know, 3 equals 1 plus 2. How the hell does it know? And here's the answer. Before, when we did .add, we still have .add, so we can leave that in there. It just won't get used quite right. What ends up happening is it says, okay, here's a point and the plus sign. It goes, okay, well, I know about this operator plus sign, so I'm calling the plus sign on whatever is to the left of the plus sign. So whereas before it said .add, one.add, now it's saying 1 plus, and it goes, plus. It's like 1 dot plus, but the dot is missing. Okay, when it sees the plus sign, it goes, okay, I'm working on whatever's on the left of the plus sign, and whatever's on the right side will become the parameter. Like that. Make sense? So, if it works, then we're done. Actually, we might already be done, right? Because the inside of this function is exactly the same as the .add method. What we need to do is get the x and y values. We get the x from the local, or the one that we're working on, which we know is 1 in this case because the plus sign is on the, move this over here. Sorry, I'm just moving stuff all around in a way that you can't see it, right? Okay. Okay, so here's our main, and here's our add method, and here's our operator-based add method that do exactly the same thing. And so for 1.add2, we know that we're working on object 1 because it is to the left of the point. For 1 plus 2, we know that we're working on the object 1 because it's to the left of the plus sign. And then it goes, well, if 2 is on the right side, then that must be the object that's in there, so that becomes the thing that's in the parameter. Okay? Yes? Everybody with me? All right. Yeah, the clock just suddenly started spinning randomly around. I was just checking because my microphone's running out of battery, so I don't want to like lose the sound. So if the sound disappears from the ceiling, you all say something this time? Okay. All right, so let's run this and see what the hell happens. So we compile it. Now we have 0.3. There are different versions, and it does pretty much exactly the same thing. Okay? Except we've done the same thing in different ways. The first add method we looked at today, the first add method we looked at today added things essentially in place. It put them into one of the objects. The second one created a new object using using the .add method. And the third thing we looked at, created a new object using the plus sign. And you can create whatever operators you want for your classes, whatever ones you want, as long as you're willing to go to the work to define what they actually do. Yes, sir. So the question is, can we use the .add method in the operator? And the answer is yes, we probably could. We could probably have plus just call .add and return whatever it returns. So, yep. Other questions? I have no idea what time it is now. All right, we have like 10 minutes left. What can we do in 10 minutes that would be useful? All right, let's make one more operator, okay? And the other operator we're going to make is to compare and see if 2 points are equal or not. Does that make sense? I've got in my bag of candy here. Who wants to try and take me down the path of what we're going to do? Kit Kat? What's everybody's favorite? Peanut butter cup? I ate all the peanut butter cups. Anybody like something that's not a peanut butter cup? Milky Way? No? You all are so unimpressed today. Yeah. You want to help? All right. So what's the first thing we need to do to add an equal operator? Yep. We need to create a prototype. So we'll say operator equal. And we are comparing with another point. So that goes in there. What did I forget? You're raising your hand. You're scaring me. Oh, yes. Question. So how does it know that the operator is both of the characters? Can you have as many characters? Yes, you can have as many characters as you want. Okay. So if you wanted, and God save you if you do this, you can have like operator dog. You know, you can do. So let me just tell you. So the question was, could we do operator point? And the answer is, I am not even so evil that I ever thought of doing that. But I will find out before the final exam. How's that? I mean, you can put whatever you want in there. The whole object of this, though, is not to like screw with other people. If you want to screw with other people, there are entire languages developed that are for nothing but screwing with other people. Okay, there are entire languages that are designed to be as illegible as possible. One of the more polite ones is called whitespace, where every reserved word in the language is either a space, a tab, or a return, so that when you type your code, nothing appears on the screen. And there's a whole computer language that uses nothing but space, tab, and return. And depending on what combination of space, tabs, and returns you're doing, defines your program. Okay, so you can screw with people if you want. Just be nice. The world's a harsh enough place that we can all be nice to each other, I think. So you're absolutely correct so far. Operator equals point. So once we define that, now what do we have to do? Okay, so help me out here. How do we write the method? Mm-hmm. Okay. We have an if statement. You're doing awesome, by the way. Keep going. I'm totally psyched. Uh-huh. You're rocking this. This is excellent. Here, I'm going to get rid of the else, just because I think we'll get a compiler warning otherwise. So, if x is equal to new point, get x, and y equals new point, we'll return true. Otherwise, we end up returning false. So let's go down here and we can test some things together. And we'll say, what do you want to test? You really want to do that? Okay, let's see if this one works first. No, we can. You're absolutely right. We can do that. But let's just test and make sure that it's working before we get really complex, okay? All right, so we say if 3 is equal to 1, 1 and 3 are the same, but should they be the same? But should 3 and 3 be the same? 3 and 3 should be the same. All right, so let's go ahead and compile this and see if it works. That worked, it compiled. 3 and 3 are the same, but 1 and 3 are not the same. All right, so we had a request to just start messing around with this, which I'm perfectly happy to help you with, except you wanted to do something like if what? Oh, yeah. You know, I think my E key is starting to double when I type it a little bit. Okay, and what do you want in here? All right. All right, so we'll see what that does. Oops. There you go. So now you have at least in this case shown that addition is transitive for point objects. So, all right, did I use the right words for that, math majors? Transitive? Pardon? Damn. All right, commutative. So no, the answer is no, I did not use the right words. Good thing I'm not teaching like, I don't know, kindergarten math, right? All right, questions about this? We're doing awesome. I hope you all understood this. This is a different way of looking at things. Next class, one of the things that would be really nice is if instead of when we created objects, if we could read things in from a file. Like remember when we're reading things from a file, we're able to put things directly into ints and floats. Wouldn't it be nice to be able to put things directly into your point object or your person object or your refugee object? Next class, we're going to show you, we just showed you how to use the plus and equals operator. Next class, I will show you how to overload the angle operator. The angle operator to do input, all right? Have a good Wednesday.